to everyone and welcome to our session today. I am Violeta. I'm happy to be joined by Emiel, Sneha, and Mohammad today. And we will, sorry about the slides, just give me a second. Today we will speak about ODSA Disaster Recovery, and we will show an end-to-end solution on how to set up an Oracle Data Guard standby database using ODSA. I will leave the pleasure to Emiel, Sneha, and Mo to give you more details about the session. What you need to be aware is that it will be a short presentation introducing the topic, and then we have a hands-on part so you can log into your Oracle Cloud tenancy if you have an Oracle Cloud account created and take this journey together with us. Speaking about our speakers, as I said, we have Emiel, who is a multi-cloud specialist. We have Sneha, who is a mission-critical database specialist, and Mo here, all coming from the Oracle EMEA team, and happy to deliver this great demo to you. I think that was all on my side. Emiel, over to you.
Thank you very much, Violeta.
You're welcome.
Sorry, it took a little bit of time to find
No
the
worries.
unmute button there.
No worries.
So all good. Right, yeah. So thank you everybody for joining. And like Violeta said, we're going to be talking about ODSA and specifically how to set up a disaster recovery setup within ODSA or using ODSA. So the topics that we're going to talk about is, I'm first of all going to talk a little bit about ODSA itself. The reason that we ran a poll earlier at the start when a subset of you had all joined was that we really wanted to gauge sort of how much you already knew about ODSA. I know quite a few people here who are in the starting block when it comes to ODSA. So I will do a little bit of a introduction, but the topic here is really to talk about DR. So we're going to do a tiny ODSA introduction. If you need to know more, and then I would advise to really go and read up or watch some of those sessions first before you come back to this. But certainly stay with us today. But you're really going to be well off to look at a few of those other things first. We're going to talk about what the considerations and prerequisites are before you set up such a DR environment, and then we're going to look at how to prepare the network setup and how to prepare your databases, and then we're going to be deploying the standby database. So all of this we will see in the introduction and the DR architecture. There was a lot of manual work here. So there were a few things when it comes to ODSA and standby databases where you don't have the luxury of doing it using the Cloud Console. So there's going to be quite a lot of manual work, and Sneha will take over at step 4B, and she will do all of that. She will show you how all of that works.
Emiel,
So
before you go into the session,
Sure,
I would like to
Viola.
run, because I know we still have a poll to run. So I would like to run this poll. Let's just use 20 seconds to launch it, because it will help us to understand the knowledge of our audience.
That's absolutely right. Yeah. So we ran the poll earlier about ODSA, but now the question is, okay, what about data guard? Because those are really the two topics that we're marrying up in this presentation.
Right. We see a lot of answers coming. As of now, people are aware of it but don't know much details. So that's nice. It means that we are exactly on the money here. Okay.
So it looks like the data guard experience is a little bit more than the ODSA experience in our audience. That's good to know. But there are also plenty of people who don't have that much detail about data guard. So we will try to.
Let's just share the results so that everybody can see them, right? Thank you all for taking the time to answer this question. Emiel, over to you.
Thank you. Right, yeah. So a little bit of an ODSA introduction then. So ODSA is a service that's been around for just over a year, and what the aim of that service is to give Azure users the experience, an Azure-like experience, but actually provide a database service running on OCI itself. So the service looks and feels like Azure. You can see the sort of Azure type of blue screen. It integrates with the Azure portal. You log on as an Azure user, completely integrated, as we said, and then you can actually provision a database as if it's running on Azure, but it actually runs on OCI. So the service itself takes care of all of the networking that is required for that. There was a lot that goes on under the water there. So within the service itself, all of the networking is set up, and it basically will provide you, like I said, with this Azure-like experience. It is as if you're creating an Oracle database service within Azure, but then underwater we sort of secretly, it's not secret, but we take care of all of the work in order to get the networking done to run the service actually in OCI itself. So that is what ODSA is and does. There's a lot more detail there, of course. If you need that detail, then we've actually done a cloud coaching session like this a number of months ago. So there were recordings of that. There's plenty of other documentation out there. This session really builds on you already knowing a few things about ODSA, and then shows how to use ODSA to set up a disaster recovery environment. So we won't go into the exact detail of ODSA itself because there just isn't enough time, but refer back to some of those earlier sessions, please. So when we talk about the architecture of ODSA, firstly, when you are in a single environment, it's really easy, right? So it takes care of all of the networking, as we said. So you start with an Azure VNet with an application in it, and then you basically use ODSA and you say, I want to create a database, and I want this application in this VNet to be able to connect to it. ODSA then sets up the VCN on the OCI side, the virtual cloud network. It sets up the database service there. It sets up the DRG, the dynamic routing gateway, which is I always call it a magic box of networking tricks. It basically connects VCNs and external network links and VPNs and all. It connects it all up together, and it makes it all work together and bootable to each other. And then what we also do is we provide what is called the multi-cloud network link. So that is that ODSA magic sauce, which does the connectivity between Azure and OCI. So when that is set up, you just go easily through the ODSA console, so the ODSA portal, and that is all set up for you. So you don't have to do anything. You just give it a CIDR range to create a VCN with, and off it goes. It creates a service, and it's now a database that you can create from your Azure side. Now, if you want to create a standby database of that database service, one option that you have is just to reach out to the OCI console and click the standby buttons and let OCI create you a standby database in either the same region or a different region. The problem with that is that the ODSA control plane doesn't know anything about that. ODSA is a separate control plane from the OCI console, so it won't be able to pick that up. So that secondary database, that standby database is a perfectly fine database, but is not under the control of ODSA. So you don't get all of the benefits of your second Azure region knowing anything about that. And at this moment, it is not possible to use ODSA to create a standby database. There isn't a button in the console or the portal that makes that work. So the other solution, if you want to have your standby database under the control of ODSA, because you like all of that automatic networking back to Azure, is to basically create another database in another region. At this moment, they're just two separate databases. You give it the same name, same parameters, same everything, and then you manually configure the data guard between them. So you copy the data files over from OCI region 1 into the standby region, and you set up all of the data guard stuff. So that is all of the stuff that Sneha will go and tell you. So the only things that we need to do for that is we need to set up the remote peering connection between those two networks. They need to be able to talk to each other. And then we need to set up all of that data guard stuff. So the majority of this session will be focusing on how to do that for that data guard stuff. I will talk just a few more minutes about how to set up that remote peering connection between those two networks to get the networks all together. But before we start with sort of all of the prereqs and all of that sort of stuff, I do need to warn you that this session will take about an hour, but it takes a lot longer than that to actually set this up. So there's a lot of pre-work that we've already done in order to show you all of this within the time frame of this presentation. But I'm now going to just quickly go out of here. What we've also published just today is this guide on how to do all of this. So we can be sharing the links, but it's basically it's on the Architecture Center within the Oracle documentation, and it's called Deploy a Multi-Cloud Disaster Recovery Topology by Using Database Service for Azure. And I'm just going to scroll down. We've got the same architecture picture that I just showed you, right? And within that, we can then scroll all the way down to have all these considerations. And I'm going to talk about all of the preparation, about setting up the network and the deployment. So all of the steps that we will show you are documented here step by step with all of these copy links. So I would really advise, if you're going to do this for yourself, then make sure that you follow that guide, that you look at this video again, maybe the recording, but also use this guide, because it's going to be a lot easier that way. Okay. So some considerations if you want to do this. So when you set up an OCI, an ODSA database, of course, you've got to determine the VCN size and the CIDR range also on the Azure side. So those first two points, they're always true, right? You want to know what the compute shapes that you're going to use. So if you do this from scratch, just make sure that you have that ready, right? Don't start thinking about it when the system asks you, but make sure that you know what you're going to do before you start doing it. You can then also verify that you have the service limit, so you don't get stuck halfway through. You want to make sure that you know what the display names of your primary and standby database are going to be, and once you've created them, you need to know what the unique names are of the primary and standby database. They will have a similar database name or the same database name, but not the same unique name, of course, because that is unique to every single instance. So the name of the database needs to be the same, because they're going to be a replicant of each other, right? Or, well, one is going to be a replicant of the other. So they need to be configured with the same database name. You need to make sure that you have the database admin passwords, and you need to make sure that you have the SSH keys, of course, for the machines that you're going to be logging onto. And then you need to make sure that you can log on the Azure side as Azure user, on the OCI side as OPC. You need to be able to sudo to root and or Oracle, and you need to be able to log on as the database as sysdba, of course. So those are all the things that you need to have ready before you start doing this. So in this session, we're going to assume that the database is already created. So you've got your Oracle DB for Azure or ODSA. It's the same thing, but a different name. You've already got your VNets and your virtual machines in both of those regions. You can connect between the two, and you've created those two databases. If we were showing that, and it would take an additional hour, so we don't want to go through all of that. We refer to other sessions. But like I said earlier, the database has been created with the same name, same database version, same editions. In our example, we have created them in UK South and in Europe West. Sorry, West Europe. Those are the Azure names. The OCI names for those regions are London and Amsterdam, but they are equivalent regions. The primary we're going to be creating in the UK. The standby we're going to be creating in Amsterdam, and then we're going to go and connect those two regions up together. Our two VNets, so our two VCNs even on the OCI side, so that the databases can start to talk to each other. So that I will show. I will show how that is done. So I will go to my console. So this is the ODSA console. In case anybody hasn't seen it before, just log on to console.multicloud.oracle.com/Azure. You log on as an Azure user, and if it's all set up correctly, then you will see this menu. We're going to be using a base database today. You're going to be seeing here that I'm connected to West Europe, or that's the Azure name, right? Because this is an Azure-like experience for people that are more used to OCI. That is the equivalent of the Amsterdam region. We have a database here that we've started using. So in this case, actually, I just happen to be doing this out of Amsterdam, which is going to be our standby region. But it doesn't really matter where I come from, because I need to be connecting the two networks together. So I'm going to go to that database, and then within the ODSA console, ODSA portal, it's called, I have this link to my OCI console. So if I click that link, I go to the service as it exists within the OCI framework. Let's call it that. So again, I'm in the Amsterdam region there. And I went straight to the database itself. If I go at the top here, one step up, the database system details. Then when that loads, I have a link here to my network, because that's what I've got to do, right? The task that we're doing now is to connect the two networks up so that the databases can see each other. So I'm going to go to my VCN here. So this is the VCN that has been automatically set up by ODSA. And as we know from the picture that I showed earlier, the task here is to connect the two DRGs up and the dynamic routing gateway. So I'm in the VCN that the database is in. I'm hitting dynamic routing gateway attachments in order to get a link to the DRG that is being used by this database. That is also set up automatically by ODSA when it set up my database. And ODSA calls every DRG that it creates the very unique name of dynamic routing gateway. So they're all called the same name, which is why this is a good way to find, if you have multiple databases, this is the way to find out which is yours, because otherwise you might just have a list of DRGs that are all called the same. But this way, I've navigated from my database to my network to the DRG that is attached to it, so I know that this is the DRG that I need. Within this DRG, I have these remote peering connection attachments, and here are the remote peering connections that I've got. So here I am in Amsterdam, and I haven't got any. Now, actually, I set this up. I'm just going to flip on the left side here to my other region. So I'm also in the UK. I prepared this earlier. I'm on the DRG that is connected to the database there, and I've got the create remote peering connection there as well. So I need to create a remote peering connection. I'm in London, so I'm going to call this to Amsterdam. And I'm just going to make sure that is going. Okay, and then I'm going to flip over to Amsterdam, as you see on the top right here, and hit do exactly the same. I'm going to call it to London. And I'm going to go back to London because that was attaching there. So I'm going to actually go to the remote peering connection itself by clicking on. So that's just the attachment that I've seen now. I have to click on the remote peering connection to get to the RPC details. And here, because I need to point one to the other, and it doesn't really matter what way around I do that. I need to copy this OSID. So I'm in the UK. So I'm copying the UK's OSIT that's copied there. I'm going to flip back to Amsterdam. I'm going to go to the remote peering connection that I've created there. And I'm going to, here, I'm going to say establish the connection. So from Amsterdam, I want to make a connection to the UK, right? So I'm going to select UK London. And there I'm going to paste the OSIT of the RPC on the London site that I want to connect to, that I copied in my previous step, and hit establish connection. So that is going to take just a minute or so. I'm just going to go back to the remote peering connections overview here. You can see here that the peering status is pending. I'm going to go back to the UK to also show you that overview of remote peering connections, and it's also pending there. Now, whilst I'm doing that, I'm just going to go and quickly just do one additional thing. I'm going to go back to the VCN. I'm going to leave those two windows open. I'm going to go back to the VCN whilst that is peering. Oh, sorry, that was the wrong link. I'm just going to go very quickly go back the steps that I was taking earlier. I'm going to let those two windows just do their peering thing. I'm going to go back to the database, and just like I did earlier, back to DB system details on the top. Let that populate the link to my VCN, because the additional thing that we need to do is to make sure that the networks are allowed to connect to each other. So we're making the connection between the two, but we also need to go into the security list. So I'm going to go and hit the security list here. I can see that my CIDR range here in Amsterdam is 10.91. I know, because I made notes of this before I started doing this, that in London my CIDR range is 10.90. So in my security list, I've actually done this already. I've allowed in Amsterdam access for all protocols, all ports from the 10.90 range. So you need to allow in region 1 all of the traffic coming in from region 2, and vice versa, of course, also. So in region 2, allow all of the traffic coming in from region 1. And when that is done, all of the traffic will flow. So that I already set up. So we're just going to go back to these two windows here. So here in the UK, I can now see that my DRG attachment and the remote peering connection is paired. I'm going to flip over to the Netherlands, Amsterdam. That was still, you can just see it flip if you looked in the right place. The peering status is now also paired. So if we go back to the presentation mode here, we can see that what we've done is we've identified the DRGs that are attached to the VCNs. We've created a remote peering connection attachment. We've then navigated to those RPCs and established a connection between them. We've created the ingress rule for the security list for both VCNs to have to connect, to have the traffic coming from the opposite VCN, and that sets up the connection between the two. We also have to make sure if you want to connect from one machine to the other, you need to have the SSH keys, and then you can test the connectivity, etc. There's some documentation that you see at the bottom here that can be used for that. Okay, so that sets up the network setup. Now we have two databases that are still individual databases at this point, right? But we can now start to use one to be actually a copy of the other, and then set up the whole standby stuff. And Sneha will take over and start presenting that.
Yeah, thank you, Emiel. Can someone confirm that you can see my screen?
We can certainly see
Yes.
your screen.
Okay,
We can't see your face on the video.
Yeah, I'm just starting the video. Yeah,
Okay.
so thank you all. Yeah, thank you, Emil. In fact, this was a wonderful live session that you showed. And folks, firstly, thank you all. And I welcome some of you all who have been there with me last year for the snapshot EXA. So I've been seeing some familiar faces. So welcome back to this session again. And an important thing over here, so if you see here, we have covered up the step 1, 2, 3, and 4, okay, especially the network setup, which Emil had shown. And we are doing a cross-region DR, right? So if the network setup is not available, you won't be able to configure the TNS entry. So you won't be able to do the steps from, 4B onwards, okay? So this step, configuring the CIDRs between both the cross regions and the DRG is important to go next. So let's have a look at the next steps. Okay, so the B, we are going to set up the DB for Azure DR configuration. Now, two things here. We are going to prepare the primary and then we're going to prepare the standby. This is very similar to what we do, in fact, in the on-premise DR configuration or in a hybrid configuration. Okay, so to prepare the primary database, obviously you will have to check whether the database is in archive log mode, the flashback is on, the force logging is enabled. Your database is in open and in a primary role. Automatic standby management is set to auto. And the best part over here is, when Emil spoke about these databases being created from the Azure, the ODSA environment, most of these things will already be enabled, okay, in the primary database. In the standby, when we replicate, there will be some changes that we will have to do, like for example the flashback, which I will take you through the demo and also in the next subsequent slides. And then you also have to set up the data guard broker configuration. This will make your life very easy to set up your entire environment. So we have switched here between the data guard broker and the SQL plus. So I tried to make things very simple. We also have the solution playbook that's been just published today, and Emil has just shown it to you, and I will take you through it also. Now, on the primary, also note down your listener status, your TNS entry, and SQL net.aura file. We will see that in the demo why this is important. Note down your configuration details, configure your static listeners and TNS entries. So this point is very important. Ensure that you correctly set this up. I have shown this very well in a demo and in the published article that's been available today. And finally, copy the password and wallet files to the standby DB system. So let's see the next what we do in the DR environment. Okay, so in this standby database, now as Emil had mentioned, we have two databases that we are going to provision from the ODSA. So first, we are going to consider the primary. The second is what we are going to convert to the standby. So this database is also created as in open mode, but later we are going to remove all the files and we are going to convert that into a standby database. A very important thing over here is you have to ensure that you create this particular database from the ODSA tooling. Okay, so that and this example, in fact, the demo also shows that you have to use the database which has been created from the ODSA tooling. Otherwise, your details will not be available and seen from the ODSA environment, though you can see it from the OCI. Okay, so in this case again, you have to note down your current DB unique name, which you will refer again and again, your database name. Note the wallet location, because the files that you're going to copy from your primary, you're going to bring and copy it out in this particular wallet location in the standby database. Ensure you note down, or you have all these SRV the database configuration details saved. Then shut down the database, manually delete the database files. Again, this is very important, that the database that you have created from the cloud tooling, you have to delete all the database files from the ASM. And then finally, copy the password file and the wallet files which you have copied from your primary environment to its respective location, and configure your static and DNS entries. So this has been, what Emil showed and what I just showed now in the A and B steps is what is the preparation phase. And now I'm going to take you to show how, what we can do with the deploy. Okay, so I have used or rather, it's a recommended thing to use the Armin restore from service. I know most of y'all who have actually mentioned that y'all are comfortable and y'all have used the, y'all have manually created the database. I'm sure most of y'all have used the Armin duplicate or backup and restore option. But try this option out. Not just for the ODSA creation, even in the other environments when, if it's a hybrid, when you're trying to do from Exadata to the OCI XADBT or any other on-premise environment, this is much simpler and easy to use from the restore. So you're basically just few steps here. You do the startup no mount, you restore standby control file from the service, you alter mount, you change the permissions at your Oracle directory, and then you restore database from service. So you end up not performing a lot of steps wherein you would be configuring the SP file separately and working manually in setting up a lot of these manual steps at the parameter end when you use this method. Please feel free to use the Q&A to put your questions. So we do have Mo and also Emil to answer your questions at the moment while I take you through the demo today. Okay, and then once you have this, once the restore is successful, you have to validate. Okay, so you have to ensure your open mode is now mounted and your database would be converted to a physical standby. Now, the example what I'm showing here is an active data card. Okay, so we will see how we can get this to read apply mode later. And because at the moment we have just done the backup and restore, so that is why we have actually not configured a proper replication. We have not enabled the the apply process or the MRPO as of now. Okay, so after this, you need to add the standby log files to your primary as well as your standby database. So I've just listed up the commands here. Uh, Once this is done, you need to configure your data guard broker. Okay, so if this is set to false, okay, your DG broker, the daemon process is not started, go ahead and start it. Also, you will have to set up the configuration files. So once that is done, now this step is again very important. You can directly use the DGMGRL. Okay, create a configuration between your primary and your add your standby, that is your the other database that we just restored. You can add that. Okay, so you have to add your service name so we are accordingly, and then enable the configuration. So once you enable the configuration, the broker will automatically set up the redo transport and the apply process. Okay, so once that is done, once your database is available, go do some log switches and then check in your DR environment. You will see this MRPO applying log files. Okay, so this is the current log sequence and that will be shown up over here. And if you see here, there are two additional processes here, MRPO and RFS, which will be started. Finally, once this all is set and once the database is replicated, validate your DR readiness. Again, I've specially put up this slide over here because we do have customers who do POCs, who create their DR environments, not just on the ODSA, but even when it comes to the other services. But they don't test, they don't do a DR drill before they go live. And that is very important because then the panic starts when you are in production, you're live in production, you have a DR and you're going to do it for the first time. So do this validation before you go live. So this is again a very simple thing. You just validate. In this case, the R2J is my standby database, and then just give the switch over to your standby database. So similarly, you can also go back. Okay, so here I'm just showing the commands to validate it. So you can see there has been a role reversal. The R2J database goes as primary, and my original primary will go as a standby database. Okay, and it will do the role reversal. Now I will take you through the demo. Just few things here. I've done a lot of pre-recording because the entire process, as Emiel said, would take more than 3 to 4 hours. And again, if you are in the production environment, depending on your data, the time would obviously increase. Okay. Now, For my demo environment, my primary and the standby, my primary is in UK South London and my standby is in Amsterdam. Emil has explained this. Both our DB names are the same, but our unique names are different. Whenever I'm referring in the demo, 898 would be my primary and R2J would be my standby database. Okay, I'm going to use Putty for my demo. The gray one with the background gray, okay, will be my primary, and the one with my white background will be my standby. Just a reminder, you have any questions, kindly post it in the Q&A. Okay, so just give me a moment. I'll just, okay. So we are on the step 4 here. Emil has already shown you all the step up till 4A in configuring the network. So we are going to prepare the primary database. Okay, so just note down your DB name, your DB unique name. Okay, ensure that you have the broker set to true. Ensure that you have your configuration files for the broker configured. Note down your log files because you will have to create your standby log files with the same size. Your encryption wallet, very important. The status should be open. Standby file management to auto. Okay, so this will by default on the ODSA environment. This would be already set. Okay, currently my current sequence is 895. My listener settings. You can get your listener.aura, and I've already configured a static listener out over here. And all this is again explained, and proper commands are available in the architecture center. Okay, my SRVCTL with all my database configuration. My TNS 898 for my primary, R2J for my standby. Okay, and finally my SQL net.aura. So this is again, this also gives the path to my wallet. Now we have to copy the password file. Okay, I'm sure most of you all would be aware, whoever has worked on this, the password file and the wallet file from this location. You have to configure, you have to copy it on your standby DB system. Okay, so that was all which we had to prepare in case when you are on an ODSA environment, because most of the things are already enabled for you by default. And we will see the steps to prepare the standby database. Okay, so here I have created a script that will remove all my database related files, files.lst. So don't worry on these commands and scripts. They are all available in the link in the architecture center. Okay, so we are going to stop the database and then remove all these database related files. Okay, so at this moment now, once the files are removed, I do not have all the old files. Okay, the password file and wallet files you'll have to manually remove and copy paste from the production. Now here's my listener.aura file, and I'm going to now configure my this thing. In fact, I've already pre-configured it over here, my static listener. So this is again a very important step. Okay, and my DNS names.aura. And all this will not work if you do not configure the CIDRs between the regions and the DRG. So that step is very important. It's only then you'll be able to do all these steps and your TNS ping will work between the regions. Okay, so we have finished the preparation part and now we are going to do the deploy. Okay, which is again the slide I had shown with very simple commands because we are now using the arm and restore from service. So we are just doing a startup no mount, no additional configuration with the SP file and all over here. We are doing the standby control file restore. Okay, we are doing a startup mount. Okay, now I have shown an additional step here, but the first time you do this, you will not receive this error. Okay, since we are doing the restore from the disk, if you see this step, this device type by default should not be there. So I've just shown how you can just clear it off in case you get into any kind of such issues with your configuration. Okay, now we are doing the restore from the service. So I'm restoring from the primary service. Now this will again take time depending on the data you have on your database. Okay, so we have now done the restore. So we have the files. We had initially removed the files and now we have copied over the files from the primary to our standby. So let's validate. We are not validating the DR readiness, but we are validating the DR as of now. So we have to check whether the database is in mounted mode and the database role is a primary standby. Okay, and my processes are not yet started. My apply is not yet available. Okay, so the next step is to add the standby log files to your primary database. In fact, from 12C, this is an important step because by default, the active data guard will be using a real-time apply. Okay, so now, as I said, on the gray is my primary. I'm back on my primary. Okay, so it's a very simple thing. You're just adding standby log files. Again, Oracle recommendation is, as per the MA best practices, to add one additional standby log file than what is available with your online log files. Okay, so similarly, we are going to add them to the standby database. Now, if you note this, we have the online log files with the primary name. We are also going to remove these and add log files with the correct naming. Okay, so I'm dropping these. I won't be able to drop the current one. So for this one, we will come back later. So let's list them down. Okay, so this one I'm going to come back later once it is in sync. Even the flashback on my databases have to be in sync. Okay, so I'll be doing that later. So let's go ahead and configure the data guard broker. I'm back on my primary. We now connect with the data guard, the DGM TRL. Okay, as of now, I don't have any configuration. I am now adding the primary configuration. So I'm adding the primary database, okay, the service names as mentioned over here. I'm then going to add my standby. Okay, so here you see I've added the primary configuration. I'm now adding the physical standby, that is the R2J. Okay, so I have the primary, I have my physical standby. My configuration as of now is disabled. So we are going to enable the configuration. And let's see, we'll just do a show configuration. Let's see if we are getting any warnings or any errors. Okay, apply lag could not be determined. So we will have to do some log switches. Let's go to the SQL Plus. Okay, just before that, if you see the daemon is, we have started the daemon process. The configuration files are set. I'd shown this, in fact, when we were preparing the primary. Okay, now interesting thing is, for those who are not aware and who are more familiar with the the arm and duplicate. When we are using this process and when we are using the broker, when we enable the configuration, the DG config parameters is set. So we don't have to perform this step manually. Okay. Also, the archive destination is set with the maximum performance mode by default. Okay. So this is also configured. So now I'll do some log switches. Okay, and just note this, we are at current sequence 900. So firstly, let's check if we have a successful configuration. Earlier, we were seeing a warning. Okay, so we have a configuration status showing success. Okay, so if you see here, okay, we are seeing the configuration for primary, the transport is on. Okay, so it is going to send all the redo to the standby. Now, that is a very important thing. So all these things will be automatically configured. Let's check for the standby. For standby, the apply is on and currently there is no lag. Okay. So let's confirm the replication at the DR side. Okay, so if you see, I had mentioned that we have to note this. We were at the current log sequence 900. So the MRPO is applying the log 900. So any redo that is there in the current log file is applied by the MRPO process in the physical standby. Okay, and we have the MRPO and the RFS processes also started. So I'm just going to cancel the recovery so that I set the flashback on. I'm restarting the recovery after this. Okay, my flashback is now set to yes. Note the open mode, it is still mounted. So I'm going to restart my database. So now it will automatically change the mounted to a read apply. So let's see this. Okay, so as seen here, the flashback is on and the mode is read only with apply. Let's do some log switches and we'll just check it again. Okay, I'm doing some log switches now. (902) on our primary. Let's check this here. Okay, so if you see, the applying log is 902. Now let's just change this particular file. Okay, so I'm dropping this and I will recreate. Again, I need to start the recovery process. Okay, I'm starting the recovery process again. Let's do some log switches. Okay, so if you see, we are on 904. Okay, so now once this is tested, as I said, this is again an important step. You need to validate your DR readiness before you go live. So we are just going to do one side, but you have to test both the ways, but we are going to just for the demo and because we are running short of time, we are just going to test it one way. Now, if you see here, I have started the alert log file of my DR. And the configuration, if you see the configuration, my current primary database is 898 and my physical standby database is R2J. Okay, so I am validating my DR environment. It is ready for a switchover. It is ready for a failover. Okay, so we will perform a switchover. So there'll be a role reversal. So my primary will be converted to my DR and my DR will be opened up for as a primary database. So I'm just doing a switch over to my DR. Okay, so you can see the steps that it will be doing in the background. Okay, so most of this is automated. And a lot of things that I've shown, like the flashback should be on, you should have the standby log files. These are all important to have a seamless switchover and failover. Now, an important thing about the flashback, okay, it's like when you have your, when you do a failover, uh, Oracle now provides you with an option to reinstate. Okay, so you can directly convert your DR, the previous DR, okay, the previous primary, sorry, as a DR to your new or a new primary. So if you don't have a flashback on, whatever steps I've shown now doing the restoration, okay, using Armin restore from service, or you can even use Armin duplicate, you'll have to recreate the uh, standby database. So having a flashback will avoid all these steps. Okay, so the switchover is completed. So if you see here, the switchover succeeded. So the new primary is R2J in Amsterdam. So let's see the configuration. Okay, so we have R2GAMS primary database and 898 has been converted to a physical standby database. Okay, so the flashback is on, read write primary database. By default, the protection mode is maximum performance. I'm at 1018. So let's have a look at our new standby database after the role reversal. Okay, so we are at 1018. Let's quickly do some log switches. Okay, 1020. Let's just confirm. Okay, there we are. Okay, so this is how you configure it, and we try to make it as simple as possible. As I said, when you're testing it, again, you can switch back to the original primary for testing. Okay, so that's it with the demo. And I think Emiel has already shown this to you all. Let me just show it again. We have just published this today. So this has all these steps. This is the architecture which Emiel has discussed. You can just go scroll down and just go to the next few pages and you will be able to find all the commands that I have shown. You can directly copy paste and use them in your environment. Okay, so that's it for now. Thank you all for being there. And yeah.
Sneha, can I ask you a quick question?
Yeah, sure.
What's the most, is there a kind of a big common problem? Like you mentioned the multiple log files, for instance. Is there kind of a basic mistake people always make or very common one that happens?
Yes. Yes, Tom, thank you for asking this. In fact, the network configuration, especially the CIDR, and when you're doing a cross region, you have to ensure that you correctly put the CIDRs in the subnets for your primary and then your GR. So with regards to the network, that is the most important thing. And we have seen, in fact, for a lot of POCs and even when the customers doing this configuration, this is something that they often do not do it correctly. They tend to miss out on it. Also, the DRG, you have to ensure that it is showing a green status, it is peered. again, in the POCs, I've seen that, the peering is not done correctly, the network is not done correctly, and they say, oh, we cannot do a TNS ping, and they try to work around with a static listener and spending a lot of time out over there. The rest, I think, is quite seamless. I mean, when it comes to manually configuring the data guard, and I've said this multiple times, you have to ensure, try to use the data guard broker environment and use the arm and restore from service, because that makes the life much simple for a DPA with less struggles. Yeah.
Cool. So it makes sense from the video, Sneha, then. So thanks for that. Okay, that was just a quick question. Thanks for that. Emiel, did you need to say something, or you okay?
No, I just wanted to, there were a few questions on the Q&A earlier about what is this applicable to, and I fear that we weren't entirely clear at the start, right? So what we've been talking about, what we've been showing is for base database. For EXA, it works in a very similar way. But we do need to make sure that people know that this is not applicable to autonomous database. You can use ODSA with autonomous database, but you cannot set up a standby database in the way that we've shown with autonomous database, because you basically cannot use the manual way to configure a standby database with autonomous. So with ODSA and autonomous, you can't use this.
All right.
Cool.
Thanks, Emiel, for clarifying it. Thanks, Sneha. Thank you, team. Mo, Emiel, Sneha. Thanks a lot for being here together with us. I know that. Keep in mind that it's going to be a database migration session in the schedule of October. So just bookmark the link to our events page, and of course register to the events that you are interested in. That was all on my side. With that, I would like to thank you all for being here today with us. Thank you, team, for this such great presentation and demo, and we hope to see you again soon. Bye-bye and enjoy the rest of the day.